everyone. I'm going to be talking about anagrams, which is a worked example for 1D lists. So there are two methods to solve this problem. The first involves a helper function called letter counts. So the first thing we do in letter counts is we create this list called counts that has 26 zeros in it. Now, each element of this list will represent the number of times a certain letter has occurred in a word. So the way that we do this is we map every letter of the alphabet to an index in our count list. So A goes to 0 and Z goes to 25. Now we loop through the characters in the uppercase version of our string because we don't really care whether the characters are uppercase or lowercase. And if the character is between A and Z, then we index into our count list. The way that we do this is by starting off and thinking that the ord of A can be considered 0. It's sort of just like our baseline. And then we're going to compare the ord of our character with the ord of A. So if our character is A, we have the ord of A minus the ord of A, which is 0. And that makes sense. And that will give us 0, which maps to A. However, if we have the ord of D, for example, the ord of D is 3 apart from the ord of A. So if we think of the ord of A as being 0, we can think of the ord of D being 3. And so that will give us our map into our count list at index 3. So basically, we go to our index that we determine from comparing our character's ord to the ord of A, and we increment the element at that index by 1. And the element at that index is just the count of the number of times that letter has occurred in the word. And so I'm going to show you an example of this. So let's say letter counts of cat. Okay? So here we see that every index maps to a letter. So we have one A in cat, we have one C in cat, and we also have one T. Now if I add a whole bunch of T's on the end of this, we see that our T count is now 6 because there are 6 T's in this version of cat. Okay, then we look at is anagram. So basically we see if the letter count of our first string is the same as the letter count of our second string. And so to look at this more closely, if I print out the letter counts of tack and print out the letter counts of cat, we see that they're exactly the same because they contain the same letters. So when we compare the lists, then of course tack and cat will be anagrams because they have the same letter count lists. Another simpler second approach is just seeing if the sorted strings match. So what we do here is we convert them both to be uppercase strings, and then we don't really convert it, but we just examine the uppercase version of it because remember that strings are immutable. And we convert that to be a list, and then we just sort the list. And so what this does is if we just print out, I'll show you, so print sorted list of cat dot upper. Yeah, cool. So we see that we get ACT, and if we do the same thing for tack, so I'm just going to copy this. We get the same sorted list. So that's another way of comparing them. Both of them work the same. They're just sort of different methods of thinking.